Good afternoon, and thank you for joining us. My name is Katie Schauer, and I'll be your host for this afternoon. You've joined us for the next episode in our Experts on Tap series. Please note that we do have all lines muted, and we will be taking questions in the Q&A and chat boxes, so feel free to enter any questions you may have to the Q&A or chat boxes. We are recording today's episode, and it will be available on our website later next week. And we will also send you an email with a follow-up link to it. With that, I'd like to hand it over to Jason Paquette.
Thanks, Katie. As Katie said, my name is Jason Paquette, and I'm an employee owner at InSource. And as a 100% ESOP company, we commit to live by four unifying principles: contribute, serve, build, and care. This simply highlights that our employees care about each other. We are building a company that is designed to stand the test of time by selflessly serving our clients and contributing to the broader community of the U.S. manufacturing. Our vision is to make those manufacturers and industrial companies more productive and profitable, ultimately revitalizing manufacturing in America. We've helped thousands of clients so far and well on our way to deliver more than $1 billion of transformational results for our clients through digitization. We don't do this alone. InSource is an AVEVA Select partner, one of our only 8 in the country. We love the cutting-edge technology of our partners, but our secret sauce is that we recognize that technology alone is not enough. So we help companies truly integrate technology into their processes and routines, and then support them for the long haul. We call it the InSource way, and time again, we've seen it unlock the untapped potential in industrial plants and employees. So next slide, Katie. And today we're bringing you Experts on Tap. Experts on Tap is to be quick, 30-minute kind of digging a little deeper into some of the issues that our consultants come across, and sometimes even our salespeople come across, and we try to bring that to light in these 30-minute Experts on Tap. And today we have Glenn Yancey, who's a system consultant with us. So Glenn, passing it on to you.
Yes, so let me go ahead and switch over to share. And once you can see my screen, let me know.
I see your
screen.
Okay, excellent. So again, this is Glenn Yancey, also another employee owner and system consultant here at InSource Solutions. So today we're going to discuss communication drivers and some of the new advancements in the communication drivers as far as what we connect to. So we're going to discuss one of the things called Internet of Things. It sounds like a broad term, but in our world, we kind of industrialize that using a protocol called MQTT, which we'll discuss shortly. We're also going to discuss in this our means of communicating via OPC UA, also standing for Open Platform Communications Unified Architecture, and how we can both be a client and a server for that protocol, which we can communicate to PLCs, but have other people communicate to us. And then lastly, we're going to discuss web services, which are services that are out there that are typically third party that have some type of information that we'd like to collect and bring back into our SCADA system. So for our communication drivers, they're kind of going through a bit of a name change. For the past couple of years, we referred to them as OI servers, but now they're branded as communication drivers, and it makes a little bit more sense. Remember, people always had an issue separating the word server from driver, and the fact that we're calling communication drivers just makes it a little bit easier to distinguish between a driver that communicates to an end device versus an actual server-based OS. So let's discuss our approach at InSource and AVEVA on where we're going with our means of communication. So traditionally, the way that we would communicate in the past is we would have an OI server, or an IO server, as we used to call it way back in the day. So in other words, our communication drivers. Our communication drivers would communicate to our PLCs, such as Allen Bradley, Modbus PLC, Siemens, Omron, and a host of others that are out there. But we're now in times where different technology is changing. We're going more wireless in some fashion, and we need to be able to communicate to remote devices that are either locally to us or geographically distributed across the country. So we can utilize what is called IoT, or Internet of Things, utilizing the MQTT protocol to communicate to a cloud, which in this case would be a broker, and in that cloud communicate to our end devices, whether or not they're a wind farm, a solar farm, anything that you can think of that is geographically remote. With those sensors or pumps, we can communicate to that via the MQTT protocol. But also, we communicate to web services. So whether or not we are utilizing a more smart city approach, where we'd like to have a SCADA system that can determine what's our weather, what's our humidity at a specific location, and a whole variety of other types of information that we can glean from that. And lastly, we also communicate to telemetry, which the focus of this is going to be more on the PLCs, the Internet of Things, and web, but we do have the means of communicating to remote types of objects as well that we typically see in power distribution, water, wastewater, and oil and gas. So we have telemetry servers that utilize DMP3 and communication to the Modbus RTUs that are out there. But again, our focus is going to be more on the PLCs, Internet of Things, and web services for today. So in our approach, we're utilizing more of a cloud-based technology to communicate. In our traditional means, we had everything local to us. We would communicate to our PLCs, and voila, the operators can get information out of that. However, we have other things that are out there due to us needing more information. So in a smart city environment or geoscada type environment, we need to pull in information from remote sources and have that go through a cloud and then come back into us. So we do have that capability in a non-traditional type of approach to get that information. But we also have remote users as well that access AVEVA-based products on their tablets, their iPhones, their Android phones, and so forth. So in essence, we're trying to set up a universal communication platform where we have means of diagnostics, where we are IoT ready, to where we can actually publish up to a broker as well. Rather than just being a subscriber, we can actually publish information up there for other clients that need to access our data. So let's discuss our communication drivers, again, formerly known as OI servers. Now, the ones that most of us use as far as PLCs are concerned are Siemens, Allen Bradley, GE, Modbus, and a variety of others. But our focus on this part is going to be more on MQTT. That's that Internet of Things protocol and the OPC UA. So as far as Internet of Things are concerned, we have a protocol called MQTT that we use. That's also going to be our driver that there used to be an OI server for it, but now there's a dedicated driver for MQTT that is separate from the original gateway. And it also supports something called Spark-Plug-B as its standard, which we'll discuss shortly. So our approach is that we've always been able to communicate locally and have that access to the cloud, or with what's happening these days is we have edge devices that sit out at remote locations that are gathering the data for us, publishing that up to a broker, and us as the consumer, the SCADA side of it, will end up subscribing to that information and downloading or pulling down what we call a payload. Payload is just, think of it as information or data that we're getting from our sources. So whether or not it's from an edge device or actually going through a cloud, these are the different types of architectures that we support with Internet of Things. So for MQTT was originally designed as a message-oriented middleware for real-time SCADA systems where you can publish and subscribe to information. As we said, we call that a payload. And that information can consolidate information from PLCs, RTUs, and other data sources. But then you have other consumers like our AVEVA systems to subscribe to that information, like InTouch, System Platform, Insight, Plant SCADA, which is known as SciTech, and Edge. So as that information is collected and published up, we also have the ability to do store and forward. If we don't have connections to our broker and we're trying to supply information up to a consumer, then our MQTT driver that now exists has the store and forward capabilities built into it. So think of it as a burst of information, very similar to kind of how DMP3 does their burst of multiple values at the same time. So that is built into our product, is that store and forward capability. Now, as I mentioned before, we had a driver called OI Gateway, and that driver had the MQTT capabilities inside of that. But now we have completely new dedicated driver for that protocol. So on the right, we see our consumers. On the left, we see what's going to end up publishing the data up. These could all be remote sites utilizing an edge device, perhaps with our AVEVA Edge system, where it also has an MQTT OI server. It publishes it out to a broker. We, on our end, subscribe to that broker to download those payloads, as we were mentioning earlier. So in this example, we could have a wind farm or a solar farm, and that wind farm has certain attributes or certain tags that we want to utilize in our SCADA system. So at that remote site, we would supply an edge system out there. And in that edge system, it would publish up all the data that it's connecting to a broker. And that broker is going to be sitting in a cloud somewhere. And there's a variety of brokers that you can use. Some are free, some you have to subscribe to based on a payment. And then we have our clients like System Platform that is going to say, there's some information on this wind farm that I'd like to be able to utilize in my System Platform application. So let me subscribe to that broker and then pull down that payload based on its structure. And it could end up looking a lot like this. This is an example utilizing France right now. And in France, in this little example, they have wind farms all over the country. And each wind farm has their own information that's collecting via an edge device. It subscribes and it publishes to the broker. The System Platform or InTouch ends up subscribing to that, therefore downloading that payload, and then having our operators visualize their graphics animating based on whatever those values are. So what Sparkplug-B gives us is something new that MQTT didn't really give us to begin with. It didn't really specify a topic namespace traditionally with MQTT, nor did it really define a payload representation of that data that's being published or subscribed to. So what the Sparkplug specification does is it gives us context and structure to this information in the payload. So more specific to real-time environments where we need to get data live, it does this by defining a standard topic namespace like we see here, where we're able to drill down through topics, individual groups, all the way down to the end device, and then give structure to our payload, so values that we're getting out of the system based on our temperature sensors and voltage meters and whatnot. That gets now placed into a more defined structure that is set up in a binary type file so that it's more efficient in how it utilizes the MQTT protocol. Because MQTT is not really meant for high speed. It's more of a low bandwidth type of protocol. And in this case, it suits us well because we're not needing values that are changing at very, very fast rates. We can do with a little bit of latency here and there. But the payload definition that's here provides us a lot more efficiency in that realm. And also, what Sparkplug-B provides for us, utilizing in MQTT, it gives us state information. So, are our devices up and running, or are they down? And if they're down, are there any error messages as to why they're down? But if they are up and running, then let me be able to discover those devices and drill down to find the actual attributes or tags that I'd like to connect to for my SCADA system. So Sparkplug-B gives us a standard and a structure that traditionally MQTT didn't give us, but now we have that additional layer for that. So with Sparkplug, we're able to browse, as long as we connect to a broker, we're able to browse through our driver and visualize all the different devices that are out there. So you may have different groups and subgroups of certain geographical areas like California Central, California Northern. As you drill down into them, you see the individual remote sites, such as Monterey or Fremont or Eureka, and then you're able to drill down into the actual sensors or end devices. And it exposes that topic namespace structure for you. So that's one of the really cool things is it kind of maps out, once you connect to a broker, it maps out all your devices. And you can also visualize this in more of a geolocation type of format, where I can see on a map where are the different locations, and let me select a location and expose the different attributes that I need to pull into my driver so that I can connect to from System Platform or InTouch. So let me do a very quick demo, just kind of highlighting what the driver looks like when we're connecting to it live. And in my case, I have a broker that's connected to something called HiveMQ.com, and I've already validated and my address and port. Now with MQTT, you can supply credentials. In this case, this is just me doing a demo, but in the real world, I would probably encrypt my communication. I don't want anybody to have access to the payloads that I end up downloading. And I want to supply not just credentials, but a security type. Because right now, I'm in an insecure state as far as my driver is concerned. So as I go to the browser, having made that connection, I can see what exists out there based on what that broker has had published to it. So from this end, I'm a subscriber. From the other end where my remote devices are, they are the ones publishing the data from an end device up to where I'm currently located. And as I was mentioned before, this is one of the things that we can see on an end device. If that end device is down and I cannot communicate to it, the fact that I have state management can tell me that I can't rely on that at this point. So I may have to utilize some of the other attributes that are out there for other locations. And I can also drill down into some of these locations. There's one here that is sitting outside of Nigeria that I can select and expose this could be an oil platform, exposing a few attributes of that particular platform. So once I have that, then I can create a topic based on those attributes and pull them in, which I've already done. In this case, I'm connecting to a solar farm where I'm visualizing battery voltage and whatnot. Now, in my InTouch application, what I did was connected to this topic in what I have called an access name. So in that topic, when I select the window, those attributes that I have subscribed to via the broker are now coming into my InTouch screen. So I can see at a solar farm, what is the weather there? Is it cloudy? Is it sunny? And I can also pull in other information such as graphics. It can provide me URL to specific JPEGs, bitmaps, and other files that I can utilize based on, if it's cloudy, then show me a picture of it being cloudy. If it's misty or rainy, then show me that as well. But here I'm also supplying the voltage, so I'm reading from that, and the battery's temperature, and the outdoor temperature, all via MQTT's driver. So let me go back into my presentation, and we'll proceed on to OPC UA. So OPC UA, as we mentioned before, is a protocol that means Open Platform Communications Unified Architecture. In layman's terms, think of it as, rather than me using a specific driver, think of it as a driver being in the end device itself. All I have to use is a generic OPC UA client and communicate to that driver, or to the PLC in this case, via the OPC UA protocol, provided that the PLC has that endpoint interface. Once I do, then I can browse that PLC and pull in the necessary structures for me to utilize in my SCADA application. So OPC UA for us can be used as a client, and starting in 2020, we can now utilize that the OPC UA protocol as a server for System Platform, which allows an OPC UA client to browse our Galaxy, provided you have the right credentials, to pull back information out of that, browse it, and then connect to those tags from a third-party system. So we do have the capability, but again, in that case, you're going to need to have the right security credentials to get access to that. So let's take a quick look at the client side of how that is set up. Now, in my driver, my OPC UA driver is located in what's called an OI gateway. That OI gateway used to be called FS Gateway. It was a protocol converter for things like DDE, SweetLink, OPC, but now supports OPC UA. And here, what I had to do is to connect to an OPC UA server that I have running on my machine, and I've already made that test. And then as soon as that test works, it exposes all the different namespaces that I have access to. In this case, my driver is a process driver or an OPC UA driver, and I was able to browse that structure through that driver to see that namespace I was mentioning earlier. So if I have a simulation that I need to have access to show a sine wave or a bell curve or whatever that may be, then I can utilize this just for simulation. But in the real world, you might have a Control Logics PLC or Compact Logics that has an OPC UA interface where you're connecting to your UDTs and their instances. So you would be able to browse through that and then pull that through into this interface. And then for the next piece we're going to discuss is the web. So for web services, you have two main types of web services that we can use. Either SOAP, which stands for Simple Object Access Protocol, or REST, which stands for Representational State Transfer. It really depends on the web service that you're using. I was actually trying to use a web service earlier on in the week to test, but unfortunately, some of the web services you have to subscribe to from a payment perspective, and it gives you an actual token and a user and password to utilize. If you don't have that, then you're not able to connect to that web service to pull information down from or write to. The one I was going to use was a wine-based where I can say, here is the meat I'm going to eat for supper. Here's the steak, or it's lamb. If it's lamb, the value may come back as Pinot Noir. If it's steak, it may come back as Cabernet Sauvignon. That web service, I was able to at least make a connection to, but not having the right credentials did not allow me to interact with, so it got denied access after that point. So what I had to use in this case was a couple web services, one that utilizes SOAP, and that is going to be based on a currency protocol converter, or currency converter, and the other one which was REST-based, which I think I had a temperature converter in there, where I may have them in reverse. But still, with web services, there are things that third-party applications provide for us that we don't have running on our machines, but we still need to have access to that. So as long as a web service exists out there and we have the right tokens and credentials, then we're able to communicate to that via those two protocols, SOAP or REST. So let's take a quick look at how that is set up and a very brief demo of that. So now I'm accessing my web services driver that was also an OI server, but now is a communications driver. And as you can see, as I drill through that driver, there is a SOAP-based interface and a REST-based interface. So for the SOAP interface is actually a temp converter. I had them in reverse. The way that this works is you have to communicate to something called a Web Service Description Language File, or an WSDL. And if that web service has that interface, then I can connect to it, and it will expose different functions that I can use to maybe perform a conversion of temperature from Fahrenheit to Celsius or Celsius to Fahrenheit. So I made my connection, and hopefully it says connection successful, which it did, and then it exposes, hey, what operations do you want to utilize based off of that? Do you want to convert from Celsius to Fahrenheit or Fahrenheit to Celsius? Think of these as topics in certain aspects. I created a generic device group, which will then allow me to browse these individual attributes that are listed here. So I'm going to do a test. A connection to web service failed, which I'm not quite sure why it had failed, but it was working fine earlier. But anyways, the inputs and outputs that come back from that then get exposed, and I can drop that into my device items. So the address to access my conversion, it may be kind of a long path, and I don't really want to put that long path into my item address for my tag, so I'm going to give it an alias, give it something a little bit shorter to identify that by. So now I've done that by putting Celsius and Fahrenheit in there, and my inputs for C to F, Celsius to Fahrenheit, and then F to C. In this application, for my soap, I can supply a value such as 55 degrees Fahrenheit, and by putting in 55 degrees, it goes to that web service, and it comes back with a value of 12.8 Celsius of that conversion, and vice versa. I can put in the temperature in Celsius, let's just say -8, and the value that it comes back with is 17.6. So in this case, web services can be used to pull information from, as well as even perform calculations for you. Now, the next one I'm going to discuss is a REST-based interface. So REST stands for Representational State Transfer, and it does require an HTTP interface for this and 2 endpoints. Now, this one is doing a currency conversion. So I'm connecting to that URL via that HTTP that I mentioned earlier. I'm connecting to that and exposing specific attributes. So in this case, there's one called currency that I'm going to use. And then if I have to have a user and password to connect to that, because it may not be a free service, then I have to enable my authentication credentials. But thankfully, this service that I'm connecting to is a free web service. But just keep in mind, you may end up having to pay for your web services that you're connecting to. And for those web services, you have different means of how to interact. Am I going to get or pull from, or will I need to post or put, which actually writes back up to a web service if I need to adjust values in the system? In this case, I'm just doing a simple get or a simple read from that. And then as I scroll down a little further, then I can actually expose the different attributes that I can pull into my device items. So I've already done that a little bit earlier. I've created a device group, which I said get money, and then device items. These are the ones that were exposed for me. And I just changed the ones that I was going to use because I don't want to utilize a long alias or a long attribute name. It's a little bit easier for me to use and match in my tag structure. So in that case, I have one called USD for US dollars, concurrency for which currency code am I going to use. And then in my InTouch application, I've created an access name that connects to those individual attributes and one that says, what's my current currency? So if I'm in the US and I want to see, perhaps when things open back up, I want to travel, I want to see what the currency for the day is. It says in Europe, a dollar equals 0.85 euros. So I can do this vice versa. And by changing it, it also downloads a URL for my JPEG file showing me a dollar or a euro banknote, and also shows what are the different currency rates for the other ones that are out there. So web services can be utilized in a variety of ways, not just for traditional SCADA, but for other information that may be used in context with values that we have coming into our SCADA system. So that is the end of the presentation, but just want to throw out there that in 2017, Update 3 Service Pack 1, they did release something called the Enhanced Security Server, which allows you to encrypt communication between your end devices and your drivers. So that is out there, and that is something that is part of all of our communication drivers for AVEVA. So out of a summary, we have drivers that can fit all types of applications and communicate to all types of applications. We're not just restricted to SweetLink anymore or traditional OPC. We can now be an OPC server and allow you to communicate to that, or we can publish data up into an MQTT broker for other third-party clients to access, provided that they have an MQTT client for Internet of Things. So that is the end of the presentation, and I want to say thank you for sitting in for 30 minutes as we go through these. This could be a much longer presentation, but we're just trying to consolidate as much as possible. So Katie, I'm going to go ahead and turn it back over to you.
Great, thanks, Glenn. We do have one question that came through. If our ERP or maintenance system exposes information via web service, could we use the web service communication driver to interface to those?
The answer would be yes, but we would need to know what type of interface. Is it going to be more of a REST interface, or is it going to be more of a SOAP interface? But if that is the case, then yes, we can use either or. If it is a SOAP, we just need to make sure that there is a WSDL file that we can communicate with. But once we have that, then we're able to use our web service driver to get that information from the maintenance system.
All right, that looks to be all the questions we have. I would like to thank everyone for attending today. Thank you, Glenn, for your presentation. And we will see you guys back in November for our next episode. Look for an email coming out shortly about that information. We will have the recording on our website next week. And if you do have any further questions or would like more information, please contact us via our website, insource.solutions. We've got a contact us box right at the top there. Or you can email us at communications@insourceff.com. Thanks and have a great day.